Hi, Lionel. Hi, Stefan. Hello, everybody. It's very nice to be with you today. I'm going to talk about the main results of an environmental health study. Well, as you know, odor air pollution is a major public health issue in the world, leading to 500,000 premature deaths in the European Union in 2015. This study concerned the Martigues conurbation. It is an urban industrial area located in southern France, open onto the Mediterranean Sea, nearby the biggest industrial area in southern Europe, namely Berre Pond, Etang de Berre in French. Well, the pond is surrounded by major industrial complexes and oil refineries, and experiences high levels of air pollutants impacting the health and the well-being of the citizens. Martigues conurbations gathers 3 municipalities, Martigues, Port-de-Bouc, and Saint-Mitre-les-Remparts, with a total population of 71,000 inhabitants in 2015. The study investigated the potential relationships between air pollution, socio-economy, and proven pathologies. We worked at the infra-municipality scale, at the irises 1. That means at very fine scale. And of course, we use Bayesian lab to study all these links. The data for 45 pollutants were provided by the Certified Association of Air Quality Monitoring in South France, called Atmosud, half in gaseous form and the other half in particle form. Their levels were estimated both on models, means air emission inventories plus dispersion, and on measurement, means long histories or one-off campaigns carried out in recent years. The pollution measurements were at the scale of urban areas, which enable us to have a more accurate measurement of pollution in the population's living space. And this, all the more so, irises could be vast and their population sometimes get rid in a single area. In addition to the 45 air pollution variables, 109 chemical analyses, that means bioimpregnation measurements, were carried out on lichen samples in September 2017 by the Institut éco-citoyen pour la connaissance des pollutions and on specific plots. Looking to the bioindication, several indicators relating to the biodiversity were calculated, namely index of atmospheric purity, lichen diversity value. These measurements on living organisms, such as lichen, are very useful to limit a confounding factor that could be linked with the residents' way of life more than with the effects of air pollution, notably addiction to smoking. Incidentally, most of the lichens plots are located in socioeconomically disadvantaged irises. We have also retrieved 7 socioeconomic variables, as the air pollution effect will not affect everyone in the same way. The disadvantaged communities may be more exposed to air pollution. Yes, we have also tried 7 socioeconomic variables, as the air pollution effects will not affect everyone in the same way. And the disadvantaged communities may be more exposed to air pollution, but also may have less resources to counter them by postponing medical consultation, by lack of resources, or by asthma and diabetes poorly controlled. These variables were provided by the National Economic and Statistics Institute, including the number of people living in household for more than 10 years, and it gives us an idea of the exposure, the number of unschooled people, the number of people living in single-parent household, and so on. we use disaggregated variables and not a composite index to precisely investigate on which variables the difference between irises could be. Oops, sorry. For each pathology, we retrieve the numbers of hospital admissions for patients having stayed at the nearby hospital and classified into 3 age groups: below 15 years old, from 50 to 65, and over 65. The pathologies known in literature as being connected with this kind of pollutions are cardiovascular and respiratory diseases, diabetes, bronchus and lung cancer, bladder and kidney cancer. In total, 178 variables were measured within 30 iris areas, corresponding to 5,340 data. The data were integrated within a Bayesian model. Data were testing for normal distribution by the Kolmogorov-Smirnov one-simple d-test, and the correlation analyses were performed using the parametric Pearson test. The variables are then, as you know, represented in node form, and between the nodes, causal links are drawn using an unsupervised artificial intelligence learning algorithm of the maximum spanning tree type, meaning that the algorithm will run until all the variables are connected with each other. Here, for Bayesian network, each type of variable is characterized by a specific color: orange for the disease, green for the lichens measurement, purple for health pollutants, and blue for socio-economic ones. What is particularly interesting is to see what happens for the links between a pollutant and a pathology. For example, between respiratory diseases for 15 to 65 years old people and benzo fluoranthene, or between cadmium and diabetes for over 65 years old people. Here, with the monitoring, we focus on the interaction between lung cancer from 15 to 65 years old people and fluoric acid, and the interaction between diabetes for patients over 65 and the heavy metal, the cadmium. Acid fluoric is very aggressive for the mucous membranes, and cadmium disrupts the metabolism of insulin in pancreas. We monitored the variables and see what happens for their modalities. What is particularly interesting now is to force one of these classes, one of these modalities. For example, the modality corresponding to the highest number of hospital admissions. Which then becomes green, and observe how the associated probabilities of fluoric acid are then instantly updated, which means that when we are considering the highest number of hospital stays recorded for lung cancer in the over 65 years old people in this territory, it is in relation with the highest value of the acid. A relation also occurred between diabetes over 65 and cadmium in its particular phase. Cadmium is absorbed in food via deposit, air-to-soil pollution transfer, but the fact of inhaling particles in the ambient could also disturb insulin metabolism in the pancreas. This relation is very strong for the highest modality of diabetes patient and concerns a value of CDP between 0.214 and 0.250 microgram by cubic meter. From now on, the irises variables become a target variable. We have used the supervised processing algorithm of the augmented naive type run on the irises target variable for the pathologies. Sensitivity analyses are then resulting from that algorithm. This chart represents all sensitivity analysis per pathology where we can observe the heterogeneity of the irises. Subsequently, we have retrieved the probability alpha value for each iris and divided them by the percent of individuals in each age group so as to eliminate possible size effects in case the number of elderly people will be proportionally higher in one iris than in others. These values are then integrated within an ascending hierarchical clustering so as to form groups of irises with a similar age profile. 5 groups of irises can be clearly distinguished. I will show you them over the maps in a few moments. Then we were looking for the causal factors of these health profiles, which can be either of an environmental cause and or a socio-economical one. The combination of both environment and socio-economy can form what we call pathogenic spaces. Then sensitivity analyses have been carried out on each iris, taking simultaneously into account of 69 main variables. Once again, the irises profiles were very heterogeneous, both in terms of quantities and in terms of dangerousness of pollutants. Meanwhile, the socio-economy could worsen or offset the situation. Then, for each sensitivity analysis, we have taken the highest probabilized variable. Thus, by example, for the first iris, we took the first variable that comes out with a 0.46 value, which indicates its level of probability in that iris. That means 46%. This pollutant is followed by 9 others belonging to the PAH family. These readings have enabled us to distinguish 3 main families of irises. Irises where pollutants were many and form what is commonly called a cocktail of pollutants, which could contain either a majority of PAH or a majority of PCBs or else pollutants that did belong neither to the 2 that I have cited and that we have designated as others, but which deserve attention. We then map the results of the sensitivity analysis. The group 1 includes atypical iris areas with the highest occurrence rates for all pathologies and an exposure to harmful pollutants like dioxin, like furans, like CB28, and so on. In 4 of the 6 irises, socio-economy, represented by white squares, combines with the pollutants and correspond to single-parent families. The second group differs by less cardiovascular, respiratory, and diabetes diseases, but a higher rate of lung and bladder cancer. In this group, socio-economy, namely unschooled at 15 years old and unemployment, had a pernicious impact. The type of pollutant, PCB, vanadium, and their multiplicity, 11 different pH, could explain the pathologies found. Oops. In group 3, we can observe high rates of cardiovascular diseases for young people and elderly, and respiratory diseases and diabetes for young people, mostly due to benzo, fluoranthene, and cadmium. Starting from this fourth group, the number of hospital admissions is relatively low. We observe a disadvantaged socio-economy, which plays a role on the cardiovascular diseases. Finally, the control group was characterized by an overall number of pathologies lower than elsewhere and less dangerous pollutants and/or in a lower quantity. Moreover, socioeconomy is more favorable and tends to offset the pollutants effect in that group. Here the synthesis map, where we can observe the PAH emissions in the southern part of the Pays de Martigues, vanadium and SO2 pollution in the southern district of Martigues, a PCB pollution distributed over the territory, and an underprivileged socioeconomy in the center of the Pays de Martigues. We have found several links and thresholds between lung cancer and fluoric acid at a very low threshold, between diabetes and cadmium, and between respiratory diseases and benzo-fluoranthene. We have observed the role played by chrome and vanadium respiratory diseases, a diffuse PCB pollution over the territories. Meanwhile, the socioeconomy plays a key role with the single family and the unschooled people. I would like to thank you, Lionel, because I really know that without using Bayesian, I couldn't reach such results. What's next now? We are going to phytoremediate the pollution in the soil by specific plant, and we are going to set up preventive action with regard to the socio-economy. The result of the study have been published in the Environmental Research Journal. Then I have finished my talk. Thank you for listening. Sorry for the mistake. And if you have any questions, it would be a pleasure to reply them.